Action.
Good morning. Thank you for accepting and coming to this interview, Virginia, Pietro. So I would like to start with a brief introduction. If you can introduce yourself, who are you, what do you do, what are your interests in the neuromuscular diseases? We can start maybe with you, Virginia.
So my name is Virginia Arechavala Gomeza. I'm a pharmacist. I have a PhD in neurology, in ALS. And I started working in Duchenne muscular dystrophy around 20 years ago when I joined Francesco Montoni to do preclinical and clinical trials for eteplirsen. I've always been interested in developing drugs for whatever I'm been working on, and for the last few years I've been very interested in developing new methods to deliver oligonucleotides to muscle mostly, and I've been working in a large network of researchers working in that field. So I've been in the field for a few years, and I think I'm extremely excited with how things have turned out. How a few years ago there was pretty much nothing, and how now there is a variety of approaches that we can test.
Excellent. What about you, Pietro?
So I'm Pietro Spitali. I work as an associate professor at the Leiden University Medical Center. I was trained as a biologist in Italy, but I moved to the Netherlands in 2010 to work on exon skipping and Duchenne and Becker muscular dystrophy. And I now work on serum biomarkers and muscle-related biomarkers in multiple neuromuscular conditions. And yeah, I work at the human genetics department. Yeah.
That's perfect because links us with the next question. So we have, in this Congress and in many Congresses, we see results of clinical trials, right? And how the pharmacy companies deal with identifying improvement changes in patients' trajectories using muscle function tests. But you have, a part of what you have described, you have been involved in trying to identify changes, more in the muscle sometimes or in the serum. It's a question for the two of you. So what do you think is the role of these biomarkers of for example, if we focus that in Duchenne, what is the role of dystrophin expression and what are the challenges that you face when you try to measure that in the samples that you get from a trial, for example?
I think being able to measure efficacy of any drug is complicated, and this is a field in which there are lots of unknowns. If you're working in another field, like let's say if you're developing a drug for high blood pressure, everybody knows how to measure that. Everybody has some standards. Every lab knows how to do it around the world. The thing is, we are starting from the very, very early stages, so we don't even know how to measure some of the things we're interested in increasing, such as dystrophin. When we started with the dystrophin trials, measuring the effect of the drug, or if you said you have a drug that is going to increase dystrophin expression, you need to know how to quantify that. And everybody had their own recipe for that, because if you're doing something for cholesterol, everybody knows how to measure cholesterol. You have it in your blood test, and it's pretty easy. But for that, you need first to validate your standards, and you need to make sure that everybody does the same thing the same way. So I think for things like biochemical outcome measures, we first need to set up some ground rules of how to do things, and then you need to see how relevant that is for the patient. So I think there's a lot of work, but there's lots of things that have been advanced in the last few years.
Okay, good. And what is your perspective of looking at biomarkers and using them as an outcome measure for trials?
So I think there's some moments where you read papers that you understand things better, and to me there were like two things that really made me think of, wow, we need biomarkers to understand response. One was the phase 3 trial with dizapersen, right? That the pre-specified power was 80%, and then at the end it was like 50. And then in the end you don't know why the trial failed, right? Because it's because the trial design did not capture the trajectories, or because the drug didn't work enough, right? Of course the drug wasn't perfect, but we couldn't measure it efficiently. And I think also that some outcome measures that are used are sensitive to motivation, right? So I think it was an abstract that showed that if you give $50 to patients, they perform better on a 6-minute walk test, right? That's a lot cheaper than some of these high-end biologics. So I think biomarkers, it depends what you want to measure. You can measure things in serum, you can measure things in muscle, and I think one thing is the drug engagement. So, like for example, for exon skipping or gene therapy, you make dystrophin, right? But the question for me is most important is clinical. How are the patients doing, and can we monitor that objectively, and eventually short term, right? What I see, and I'm not a clinician, is that trials need to be long enough, and especially the longer ones, kind of provide more insight in the drug, how the drug is performing. Like you need, for Givinostat was 1 year and a half, right? You see also trials of 2 years, but in 1 year duration, it's difficult to detect meaningful, clinically meaningful and statistically significant changes, right? What I hope to do, right, what I would like to do is to enable a trial that lasts like 3 months, 6 months, right? And you have vision of the long-term clinical trajectories, right? So you reduce the exposure to potentially harmful drugs in 3 months or 6 months, but you have a long-term vision of the response to the treatment. And that's the dream, right? And the work I think I'm doing, but also others in the field, I think goes into this direction. And you asked muscle and serum, right? I work on both. Muscle because you understand the biology better when you look at the tissue that's affected. But we know that if you sample in a muscle that's more glycolytic or oxidative, or you sample 5 millimeters up or down, you have different biology. Yeah? So it's not, I think, totally representative of the status or the function of the patients. And for that, I think if you look at blood, it's more promising.
That's excellent. But so for me, when I look at what the companies are doing, my impression is that they are paying less and less attention to all these changes that are happening in the muscle, which is a pity. We have just seen symposium right now where they have taken muscle samples, but they are not doing too much with them, and they are focusing and putting everything on changes from a functional level. So, which as a clinician, I can tell you that the variability is huge. So when you ask a patient to walk the 6 minutes walking test, just control, you will see a lot of variability. So I am in favor of measuring other things. But what do you think is the missing piece here? Why are the companies not interested in investing more in finding biomarkers, in using muscle samples for that? Is because we don't have a direct link with or a correlation between these biomarkers and muscle function? Is because they think that this cannot predict anything? What is your opinion about that?
I think it's different for a company because obviously the best thing that you want is an outcome measure for the patient and something that is going to change their lives. And that's your final goal. The problem is that sometimes you want to get there before you've been through the many steps in between. And I think we cannot really afford to stop looking at everything, because right now there is so much we still don't know that I think probably you may get to the end and not have the answer you were looking for. And perhaps there are some answers to that somewhere in those samples that you didn't analyze. And sometimes it's just that you don't have the proper tools to analyze that yet. I think there's so many things that we've learned along the way. It's like you cannot really have an effect and know that it's relevant unless you have a natural history of the disease. And that is something that wasn't there when some of the trials had started. You cannot really know if your protein is enough if you haven't done all the basic science to know how much protein do you need to it for it to be relevant. So I think there is still a lot of work to do. And sometimes there are people that, it's not people, it's just that companies obviously need to get their investment back and they need to get a result quicker. And sometimes they may want to get to the end, and sometimes they need to. They will go back. If they have the samples, they will probably analyze them later on. But I think there is a lot of basic science that you need to implement in those trials as well. So then you can know exactly what happened. It's not the first. It wouldn't be the first time that they need to go back and reanalyze the data and go back and perhaps make smaller cohorts and do post hoc analysis on what they have. That has happened many times before. And I think it's probably, it's been quite a few years, but if you would see how much the field has changed, you see that you do need all of that kind of data. You need natural history, you need biomarkers, and you need to know what those proteins do and how they do. And the problem is that in many cases, we're still learning the basic biology, so we need still to know what we are doing. So we may think that it's on dystrophin, but you also need to keep the muscle well enough to get that protein back. If you don't have any muscle left, it's impossible to get dystrophin back in. So I think there is still a lot to do in basic research and also in clinical research, not just on the clinical trials, and just understanding the disease and understanding the pathology. And I think we still have a lot to do.
Yeah, I agree. You want to add anything to this?
I'm a bit ambivalent on this. On one side, as a researcher, I would like to have access, right, to these samples and understand what happens. On the other side, I understand that when they are in the clinical program and you do some untargeted studies, you might find things that could jeopardize the program, right?
Yeah, that's
so that I understand that that companies don't want to take that risk to some extent, right? But also the knowledge that we would get by analyzing, for example, response to the gene therapy, right? In the context of Duchenne, is it better to have 50% of microdystrophin or 5% of skip dystrophin, like this sort of questions? I think it would be super valuable to know.
Yeah.
But it's very difficult to convince them, like, to try to answer this question, which is a research question that may affect their clinical development, that would cost them $1 million, maybe part of the program. So I think I find little leverage to convince them, except for, igniting some of the curiosity in investigators there. And I think it's, I hope there will be more room for that, especially in phase, for the accepted drugs, right? We will also see patients that have been exposed to drugs in phase 4, right? So, and then we will probably be able to analyze and correlate or compare to historical controls in that sense, or to the placebo. I hope, right? But I find it difficult to sort of push that and to get access. It's the researcher in me. It's a bit sad about that. But
no, we are all sad about that.
Yeah.
Difficulties in having access to that, not only the samples, also the data from trials, baseline especially. I understand that when the trial starts, it's complex, but baseline samples that would sometimes they are just in a freezer.
And also a placebo sometimes.
And sometimes the placebo ones. Yeah, you are completely right. So focusing a bit on the research that you are doing now. So Virginia, you have been involved in the development of antisense oligonucleotides for 20 years, you said. So, but the field has changed incredibly. So we have now new platforms of delivery. You are working on that. What is your view of this change since you started to now, and what are the challenges for these treatments?
I think if we are thinking in neuromuscular disorders, the liver is still the big problem, because for some of the fields, such as liver disorders and oligonucleotides, GalNAc conjugation has changed. It's been like the eureka moment for them, because they could open that door, and that's why many of the drugs that we are seeing in the field, they are targeting the liver or something that has to do with a liver involvement on the process of that protein. For us, there's still delivery to CNS and to muscle is still a big problem. But the good thing is that there are lots of different options that are being investigated right now. There's either different conjugates or different peptides or different antibodies or endosomal escape. So I don't know which one is going to be the best one. There might be a combination of several. But I think it's exciting to see that there's so many people working in that field, because one of them is going to find the key for muscle. So I think on one side there will be lots of people working on different approaches to try to get that cargo ready for whenever that delivery van is ready. So I think there's it's exciting because you know that there are people working in that field. I mean, we all need to collaborate to be able to get that done. So I think there are people working on, that cargo and to those sequences that may adjust that particular protein of interest. And then there are other people trying to work on that the delivery options. So I think that is exciting. I think it's coming. It's probably not coming at the pace that we would have liked it to happen. It would be great if we were working in something like the liver or the eye, that they seem to be running faster. But I'm cautiously optimistic on the pace that is taken.
Just to continue on that, so we focus on Duchenne, it's a disease that you know very well. What I see as a spectator is that you have the oligonucleotides and all the research, but at the same time you have a competency now with all these gene therapies. Do you think that there is a risk for people working on oligonucleotide that gene therapy ends up being like what all people, all companies do and forget about oligonucleotides?
I don't think there is. Perhaps patients don't just suddenly appear from scratch. They are at many different stages of development and disease, and I don't think none of those drugs is a magical cure. So I think we have still a lot of space, not just for gene therapy and oligonucleotides, but also for traditional medicine, because there are things that we can still do for patients that will improve their lives. So I think we still need to keep muscle. To be able to use any of those gene therapies and oligos, we need to make sure that there is still muscle there to recover. So I think, yes, for a smaller child, perhaps there could be a gene therapy that eventually will stop that from happening, but you need something to keep that muscle, to stop fibrosis or to get muscle management. So I think there is a space for everything. And I think in many cases there will be a combination therapy, because patients are not perfect. You need to get treatments that will accommodate for the status in which the patient is in.
Okay. And just to finish, you have been leading with an action cost on oligonucleotides. Can you tell us about the experience?
I love cost actions.
Okay.
Cost actions are great because they're networks in which you can contribute with whatever you know. It's not a network in which you create the network and no one can get in. So anyone who wants to contribute can join. Unfortunately for our cost action, funding has finished, but actually we're still working. So we are still doing whatever is free to do, like doing webinars and try to meet up and so on. So the idea of our particular cost action was to get people who knew about different things. So there were people who were experts in the disease or in the tissue, as I was there working on muscle disorders. There were people who knew a lot about the chemistry of the oligonucleotides, because they may know different options that could increase the affinity of those molecules. And they were also delivery experts. So I think that was a very good mix. Also because other than the knowledge, we had people that were either clinicians or pharma or small academics or larger companies. So with that, I think we had a very good melting pot of knowledge, of interest, and I think it's a good way in which you can contribute and create that atmosphere of collaboration and try to develop further. Because actually, we have some problems in muscle disorders that are very similar to those in people working on CNS or maybe people working in the eye or liver. So I think we found some common ground, and I think we still have a lot of things to do in that field.
Good. Pietro, now some questions for you about your research. You have been working in biomarker identification in animal models, right? Also patients. So what are the challenges that you are facing in your daily practice? For example, when you try to do biomarker discovery in patients, what are the limitations that you have?
Well, limitations. So we did work on animal models, which allow you to do, paired, for example, sampling of muscle and serum. Because many times, I would say that one of the challenges is that when you look into serum, you find associations with performance or with pathway, but what does it mean locally, right? Because you are not looking at the affected tissue, right? So I feel always a bit that I have sort of to give a biological explanation for the finding, and I find it difficult when you look into serum because it's a circulating nature of blood. You actually don't know where this molecule comes from exactly, if it was detected because there was muscle damage at that moment, right? Or because there's an ongoing and chronic pathogenic process. So experiments in mouse allow to look into muscle and serum in paired samples. That's a big plus. In the clinics, you cannot ask a 5 or 6 years old boy donating blood. That's already invasive enough to ask also a muscle biopsy with just to understand the biology. So many times you'll find with the signature, and then that's one of the challenges to explain the biology behind that. But I think that the challenges are also that we work with methods that are mostly research methods, right? So what works in my lab might not work in your lab, right? And then that's one thing that now that we are identifying proteins or metabolites or RNAs or whatever that relates to function, there will be a massive, I think, exercise, and we will need resources to sort of bring this to the next level, so that not only we in Leiden can do it, but you can do it in Newcastle, you can do it in Virginia's lab, right? And then to enable testing of patients in a non-invasive way during the trials, but also during the practice, like your yearly visit of the patients. I guess it would be nice to have, for example, prognostic markers to bring forward to also inform patients when their kid is 5 or 6, what they can expect in 1, 2, or 3 years. So not only in relationship to trials. And one thing I would like to say is that also our expertise goes to, in the lab, goes up to a certain level, right? So we need to really work with people that know what happens afterwards, bring to the EMA or to FDA, and qualify our suggested marker, work with industry, and validate across labs. So collaboration and involve people with different expertise and background. And I think that's what we need to bring this further. And that's one thing I think we try to do also with the de-risk consortium of critical path. I think that's really, because their expertise really starts where our ends. So I think it's really nice. These are just a few. And I think one of the things that we're still not looking at is we look at blood sample as something that is representative of the status of the patient at that moment, but we don't know, for example, if the patient arrives to the hospital appointment 3 hours before, was sitting and taking it easy, or was rushing to get there, right? Those will also create variation in your measurements. So there's a lot we can still standardize, a lot that we can improve, and these are like challenges, I think. The first, at least, that come out to my mind now.
Yeah, that's for sure. And you are using new technologies now, which are complex sometimes to understand. So we have seen recent papers, spatial transcriptomics. What is the complexity when you look at these, when you use these technologies? They give you a lot of information. What are the complexities that you find?
Yeah, so I think the spatial transcriptomics is one of these technologies that allows to look into thin sections, like in that we normally use for just the histological staining, right? And then you can look at gene activity within cells, right? So, and then you can see where a gene is particularly expressed and in what type of cells, right? So the technology is a tool that enables to basically answer questions, right? We had questions that are not particularly original or new, but the question that we had like 10 years ago, 20 years ago, I think we can now answer because the technology enables to answer this question. And I think the work that also you have done on single nuclei RNA sequencing is already like a big step ahead to understand what cells contribute to pathology, right? You have shown FAPS or regeneration, as well as adipocytes increase in Duchenne, for example, right? I think spatial transcriptomics allows to go one step further, understanding where the location of these changes. And I'm a bit surprised, I think, to see that the muscle field is somewhat slow to using this, acquiring or using these technologies. Other fields, like on cancer or neuroscience, are using this for a few years. And I've seen there's basically couple of posters on that, and we're presenting, and a PhD student in the group, Laura Hazen, is going to present it on Friday. I think those are tools that will enable to answer what happened at this specific spot in the tissue. Why is it fibrosis here and fat there, right? What are the cells that play a role in this context? And I hope, and I think we will see many of us working with these technologies. But you asked the challenges. The challenge is big data, right? We did an experiment a couple of weeks ago, and I think the data that came in, it was more than what I acquired in 20 years or 15 years of research, right? So that's one of the challenges, right? The data and the ability to speak with people with different expertise, right? When you talk to a bioinformatician, the clinician, and the statisticians, the biologists are all needed to make sense of the data, right? So you really need a multidisciplinary team to sort of approach this. Otherwise, I think groups might be, scared away or not do it because it's just the challenge to analyze the data is too high. But yeah.
Good. So you are both lab researchers, so you are in the lab. And you are invited to speak in a conference, the World Massa Society Congress, which is now, my impression is that sometimes it's predominated by clinicians. So what is your view about that? Do you feel that you are coming to a place where you learn a lot of things that is useful for people in the lab, or you feel that it should be more basic research or lab research present in the Congress?
I find that in general, when I do come to the WMS, I learn more from the poster sessions than the general sessions. There are a handful of lectures or seminars that I'm more interested in, and sometimes the outcomes from clinical trials are also quite interesting, but there are some clinical talks that I'm more interested in, but in general, it's true that the WMS is very clinical. So for example, for my students, I do bring them from time to time, but I think they learn more from the poster sessions. So I think I would like to see shorter talks and more basic science. I know it's not the usual for the WMS, but probably more parallel sessions with a different range of topics and interests will probably increment the amount of basic scientists attending the WMS. Because I think in some cases for us it's not worthwhile, because going to a conference is expensive. You need to get the time, the money, the effort to get there, and sometimes you're like, I'll read the paper. Whereas it's a pity, because in a in-person conference there are all those other things that you get from networking, from talking to the people, from discussing things that you didn't quite realize, and I think that is something that you miss. So probably being able to make it slightly more attractive to basic researchers will probably be better, not only for basic researchers, but also for clinical researchers. Another thing that I do miss at the WMS is more emphasis on negative results. I know this is something that I'm quite passionate about, but I think there are lots of things that we don't publish because they don't work as well, not only in the context of clinical trials, but also in basic science and in clinical science, those things that didn't quite fit what you expected. Sometimes you share those over a coffee. Oh, that didn't work for me, or didn't work either. But I think being able to share that more widely, that was something that will probably make us much more aware of things that we don't know. And also all this, in the last couple of years, artificial intelligence and all that has changed the world so much, and it's changing science as well. If we keep on only focusing on things that work and don't give the negative data, we're never going to be able to use that science, that help, that is huge help, to be able to give us answers, because they're going to be so biased towards the things that we have already fed it to the system that is not going to work. So I think probably we should start having sessions on negative results, things that didn't work, all this kind of data. So I think that's something that I would like to see at WMS.
Good. And would you like to add something else?
Well, you already said a lot. I think Virginia. The reason I come to WMS is to really talk to also clinicians that see the disease, right? So and see the patients and see what's their question, because the question is, to me, as always, the starting point, and it's a clinical question, right? Then I should sort of translate that into an experiment to understand the answer to that. So to me, that's very valuable. And well, I work in a preclinical sort of human genetics department, so we do work with patients' material, but and we have interaction with the clinicians weekly. But I think this level of interaction here helps me to understand where the field is going and what are the relevant questions. So I like that. I think maybe having more parallel sessions or also young investigators would be nice, right? And but the society is growing bigger and bigger, right? So there's a challenge also there to, keep it cozy, keep it nice, keep it informal, and also allowing, the large presentation and, the new talents to shine out, right? So there's 700 posters or more in this edition. So I think there is a difficult balance. So I think they're doing a nice job, but probably parallel sessions. I don't want to say adding a day, but I think if you want to really keep an afternoon to walk together informally into the city center, so to enable that interaction, but give you more opportunity to present. Either you expand on time or you got to kill some of what is already present there. So it's a difficult balance, but I think, maybe a more parallel session on short presentations.
Well, these are excellent ideas to improve the WMS Congress. Thank you very much. I think it was great. And
Thank you for your time,
Thanks.
Jordi, for inviting us.
Thank you.